Space is a vast and unforgiving frontier. It tests human ingenuity constantly. Two NASA astronauts experienced this firsthand. Barry Butch Wilmore is a veteran space flyer. Suni Williams is also highly experienced. They embarked on a mission to the International Space Station. Their journey began in June of 2024. They launched aboard Boeing's Starliner spacecraft. Hopes were high for this new vehicle. The universe, however, had other plans for them. Their initial stay was meant to be brief, a quick trip. About 1 week in orbit was scheduled. This would test the Starliner's capabilities, but space missions are complex undertakings. Many variables can change the course of events. For Wilmore and Williams, their weeks stretched into months. They found themselves in an extended stay, far longer than anyone had anticipated. The orbiting laboratory became their temporary home. Imagine looking down at our blue planet, knowing your return trip is uncertain. This was their reality for a significant time. The ISS orbits Earth at incredible speeds. It is a marvel of engineering. Yet, it is an outpost in an alien environment. The astronauts continued their duties. They are professionals, trained for the unexpected. Their resilience was truly put to the test. A plan was needed to bring them home. The cause of their extended stay was technical. It involved the Boeing Starliner spacecraft. This was the vehicle that took them to orbit. It was designed to be a new crew transport, a vital addition to NASA's capabilities. However, during its time docked at the ISS, issues arose. These were not minor concerns. They involved critical systems on the spacecraft. The integrity of the vehicle was paramount, especially for a return journey carrying astronauts. No chances could be taken with human lives. Engineers on Earth meticulously analyzed the data. The Starliner exhibited several troubling symptoms. Helium leaks were detected within the system. More concerning were problems with its reaction control thrusters. These thrusters are essential for maneuvering. They ensure precise control during flight and critically during re-entry and landing. Without full confidence in these systems, a crewed return was too risky. A difficult decision had to be made. NASA made a cautious, deliberate choice. In September 2024, the Starliner returned to Earth. It returned, but without its crew. It flew autonomously, an empty vessel. This unmanned return served a dual purpose. It avoided any unnecessary risk to Wilmore and Williams. It also allowed engineers to gather crucial data. The astronauts would wait for a different ride. This decision underscored a core principle of spaceflight. With Starliner grounded for crewed return, NASA turned to a reliable partner. SpaceX was tasked with the crucial rescue mission. Their Falcon 9 rocket is a workhorse. It has a strong record of successful launches. Their Dragon spacecraft is also well proven. It has ferried many astronauts to and from the ISS. This combination became the lifeline for Wilmore and Williams. The mission was designated NASA's SpaceX Crew 10. Its primary objective was clear: bring the stranded astronauts home safely, and deliver a new crew. The launch was highly anticipated. It was scheduled from Kennedy Space Center in Florida. This historic site has seen many departures to the stars. However, spaceflight often involves last-minute adjustments. One launch attempt for Crew 10 was scrubbed. This occurred just 30 minutes before the planned liftoff. The cause was a hydraulic ground issue, a problem with the support equipment on Earth, not with the rocket or spacecraft itself. This led to a standard 24-hour delay. Such pauses ensure all systems are perfect. Elon Musk, the founder of SpaceX, expressed confidence. He stated SpaceX aimed to bring the astronauts back swiftly. The teams worked diligently to resolve the ground issue. The new launch date was set: March 14, 2025 at 7:03 p.m. The world watched with bated breath. The Falcon 9 engines roared to life. The journey to the International Space Station had begun. Crew 10, a diverse team for a critical task. The SpaceX Dragon spacecraft for Crew 10 carried a skilled team. 4 individuals were chosen for this important flight. Air Force Colonel Ann McClain served as mission commander. She is an experienced astronaut. Her leadership was vital. Air Force Major Nicole Ayers was the pilot. This marked her very first journey into space, a significant milestone in her career. She had completed astronaut training in 2024. She brought over 200 combat hours and 1,400 flight hours in military aircraft. Her expertise was a great asset. The crew also represented international cooperation. Takuya Onishi from JAXA, the Japan Aerospace Exploration Agency, was aboard. He brought his own extensive spaceflight experience. Kirill Peskov from Roscosmos, the Russian space agency, completed the quartet. This international blend is common on ISS missions. It highlights the collaborative spirit of space exploration. Even in challenging times, nations work together. They work for common goals in the cosmos. Rendezvous in orbit. The delicate dance of docking. After a successful launch, the Crew 10 Dragon spacecraft began its journey. It was a carefully choreographed trip to the ISS. The spacecraft traveled for approximately 28.5 hours. It autonomously navigated its way through space. This journey required precise calculations and maneuvers. The destination was a moving target. The ISS orbits Earth at over 17,500 miles per hour. The Dragon had to match this speed and approach the station with extreme caution. Docking is always a critical phase. On March 15, 2025, the moment arrived. The Crew 10 Dragon autonomously docked. It connected to the Harmony module of the ISS. This was a seamless operation, a testament to the advanced technology involved. The astronauts aboard the ISS monitored the approach. They were ready to intervene if needed, but the automated systems performed perfectly. The link between Dragon and the station was secure. Hatches were opened. The Crew 10 astronauts floated aboard. They were greeted by the existing station crew, including Wilmore and Williams. Following Crew 10's arrival, a handover period commenced. This is standard procedure during crew rotations. The outgoing crew briefs the incoming crew. 9 months of discovery, science in isolation. Butch Wilmore and Suni Williams were not idle. They did not simply wait during their extended stay, far from it. They are highly trained scientists and engineers. They transformed their unexpected situation into an opportunity for more research. By the time of their planned rescue, they had been on the ISS for over 9 months. This was significantly longer than their initial 1-week mission. They utilized this extra time productively. Their dedication to science never wavered. They pushed the boundaries of knowledge. During their prolonged stay, they conducted extensive research. Over 900 hours of scientific investigation were logged. This is a remarkable achievement. They worked on a wide array of experiments. These experiments spanned various disciplines: biology, human physiology, material science, and Earth observation. The ISS is a unique laboratory. It offers a microgravity environment. This allows for studies not possible on Earth. Wilmore and Williams contributed significantly to this body of work. Forging the future lessons from a daring rescue. This entire episode, from Starliner's issues to the successful rescue, holds profound lessons. It underscores the inherent complexities of space travel. It reminds us that space remains a challenging domain. The technical problems with the Starliner were a setback, but they also provided invaluable data. Engineers will learn from these issues. They will improve the spacecraft's design and reliability. This iterative process of learning from failure is key. It is how we advance in engineering and exploration. Pushing boundaries always involves risk. The mission highlighted the importance of robust contingency plans. NASA's ability to quickly pivot to SpaceX was crucial. Having multiple commercial crew providers offers resilience. If one system encounters problems, another can step in. The Falcon 9 and Dragon performed admirably. Their reliability was a cornerstone of the rescue's success. This event will undoubtedly shape future mission planning. It will reinforce the need for redundancy and for flexible solutions in human spaceflight. Our journey to the stars is a marathon, not a sprint.